Hey everyone, this is video 9 and where we are going to learn how to write balanced chemical equations based on words, English words instead of formulas. Okay, so you have to be pretty good at just coming up with the formulas from the names, and then it's going to be put together to make an actual equation. So for the first one, this happens to be a double replacement reaction. So we have potassium nitrate reacts with sodium carbonate. So those are going to be our reactants. Potassium is always +1, so that's K. And you can actually write it up here if you need to. Nitrate is a polyatomic ion, NO3 minus. Crisscross your charges, and it's +1 -1, so they just cancel out. So KNO3 is potassium nitrate plus sodium carbonate. So let's write that out. Sodium is Na, it's always +1. Carbonate is again a polyatomic ion, CO3 2-. Okay, so here we have different number of charges. We're going to have to crisscross them to make sure there's electrical neutrality. So that's going to be Na2CO3. We don't need parentheses around the CO3 because there's not going to be another subscript for that because the Na was +1. Okay, to yield, that's our arrow. Potassium carbonate, so K plus CO3 2-, crisscrossing the charges, so K2CO3 plus sodium nitrate. So that's going to be Na plus NO3 minus NaNO3. Okay, so now I have the complete chemical reaction, but it's not balanced. So we need to go ahead and take a look at what's on either side. Now, by now you should be pretty good at balancing chemical equations, but let's just take a look. So potassium, there's 2, there's only 1 over here. I'm going to put a 2 there. 2 nitrates, only 1 over here. I'm going to put a 2. 2 sodiums, and 2 sodiums on this side. So I'm probably good. Let's just check carbonates, 2 and 2. This is one where you want to balance the polyatomic ions together because see how they stay together in this double replacement reaction. So that's all there is to it. You guys are good at balancing. I'm not going to go too much further into that. Okay, now the next one example that we have here, this is a single replacement reaction. So when they say something like aluminum metal, elemental aluminum, sometimes it'll be a gas, and then you have to remember which gases are diatomic that I mentioned in the last video. But here we just have aluminum metal. That's just going to be aluminum by itself as an element, Al. Reacts with iron 3 oxide. So iron 3 is Fe3 plus. Oxide is the negative ion for oxygen, O2-. That's always a -2. Crisscross your charges. So we're going to have Fe2O3 yields iron metal, that's Fe by itself, plus aluminum oxide. So we got to figure out what those charges are and what the formula will be. Al, aluminum is always 3+. And if I didn't write that on the periodic table last time, I apologize, but aluminum is always 3+. So just know it for now. Because of where it is on the periodic table, it's easy enough to lose the 3 electrons. And oxide is going to be 2- again. Oops, I lost my draw function. Okay, so 2-, crisscross your charges, and you're going to have Al2O3. Okay, so now we got to balance this puppy. And this might be a little challenging. We'll just see. Okay, so there's 2 irons. So I'm going to put a 2 there. 3 oxygens, that's okay. 2 aluminums, 2 aluminums. Actually, that was pretty easy to balance. Okay, so you get the idea. This is just combining a bunch of skills that you already know and putting them together with balancing a chemical equation.